journals and under repute. Some of them are published in nonlinear dynamics, informatics, in medical analog, chaos solution, and Faxel International Journal of Modeling and Simulation. His work area is mostly in biomathematics and optimization also. So this session you can learn something from our own self, introduction to MATLAB. So we can start now. So this session is all yourself. You can start now. Dr. Pabik Panja, over to you.
Thank you very much. Good afternoon, all of you. Uh, First, you all open your Google, your MATLAB toolbox. Okay, then am I audible?
Yes, sir. Perfectly audible.
Okay. My screen is visible.
Yes, it is visible, sir.
Okay. So all of you, first open your MATLAB command window. You can see my screen. Okay. So actually, MATLAB means matrix laboratory, and MATLAB was first used by Clip Muller in 1960, and he was the professor of mathematics at the University of New Mexico. Okay, so first developed the MATLAB software package, and it is nothing but matrix laboratory. Okay, so using the matrix or using array operation, we can solve different real life problem with the help of MATLAB software. Okay, and today millions of users are using MATLAB software to solve their research problems and other real life problems. Okay, so MATLAB had several applications. I will tell you step by step all some of the applications. Okay, so firstly, MATLAB you can use as a general calculator. Okay, so suppose if we want to calculate like uh, 1 plus 2, okay, you can get the result. If you type here 1 plus 2, then if you enter, you will get answer 3. Okay, so there are some different arithmetic operation you can do using MATLAB. So you can take another example. So if we want to take like that 1 plus 2 into 3, you will get a result. So this type of several operation you can do. Now if you mention, suppose a variable x equal to 2, okay, then if we use the operation y equal to something 2 plus x, okay, then what will be the value? See, x value is 2 already read, and whenever we declare y variable 2 plus x, then we'll get 4. Now if I do the same thing here, see, we have, suppose x equal to some 5, okay, and if we take another variable y equal to 5 plus x, okay, and if we put a semicolon here, just see, if we take a semicolon here, your result will not be printed. Okay, so we have to open the semicolon. So if we take y equal to, suppose here 5 plus x, and if we remove the semicolon, we'll get what? 10. Okay, now we have here y equal to 10. Now if we define another variable z equal to 4y, see what will happen? You can see there is an error. So whenever we want to multiply uh, 4 with y, so we have to use a star. Okay, otherwise there will be a MATLAB error. Okay, so whenever you take 4 star y, then y value will be multiplied by 4, and you can see lastly y value was 40, sorry, y value was 10, and if we declare the variable z as 4 star y, then previous y value will be multiplied by 4. Okay, now if we take another variable, suppose w, and if we divide if we define this variable this way, z by 5. Okay, z slash 5. See what is the result? You will get the division of z by 5, that is 8. Okay, so this type of simple arithmetic operation you can do using MATLAB. Okay, now you can define several variables like C Fortran. You can define the variable in MATLAB also. Suppose we are just taking one variable t equal to 5. Okay, now we can update this variable. If we take t equal to t plus suppose 5, okay, then you will get 10. So first you can define a variable, you can mention a number for the variable, and then you can update this variable. Okay, now several types of operation you can do. Suppose we are taking one example. We are taking format sort. Format sort. Then if we divide uh, suppose 2 by 3, then what will happen? See, if we use format sort, this comment format sort, and then if we divide 2 with 3, you can see the result is 0.667. 6667. That means after decimal you can see 4 points. And if you use another comment like if you use format like long, okay, and after that if you use the same thing, 2 divide 3, see what will happen? You can see the result, but after decimal you can see how many number of digit? 1 2 3 4 5 6 7, I think like 15 digit you can see. Okay, so using MATLAB, if you want to minimize the result after decimal, you can use format sort, and if you want to see more result after decimal, then you can use format long. Okay, now in a MATLAB command window, in one line you can use several statement, like you can take suppose a equal to 7, then you can define b equal to some cos of a. Okay, and you can also take another variable c equal to cos hyperbolic of a. Okay, or you can take another expression d equal to some sine of a also. Okay, now after that if you press the enter, you will get some result. That means for a equal to 7, by taking a equal to 7 you will get the b value, that is cos 7, and c value, that is cos hyperbolic 7, and d value as sine of 7. Okay, so in a MATLAB command window, in a line you can use several many expression, okay, by taking comma, and you can try it uh, in your own laptop. Okay, now suppose we have done several many things in the command window. Okay, now if we want to clear this command window, So first type CLC. If you type CLC in the MATLAB command window, then if you press enter, it will erase all the previous result. Your MATLAB comment will be clear. Okay. Now suppose uh, okay, suppose you are just taking some expression value a equal to 5, x equal to some 2, and y equal to some 8. Okay, then if you want to calculate this expression value y equal to something e to the power minus a, how can we write e to the power in MATLAB command window? Say it. If we want to write e to the power a here, we have to write exp, within first bracket we have to write an a. Okay, now if we want to calculate, then if we want to take the multiplication of exponents e to the power a with sine of x, see, we have to write star, then sine within first bracket x. Okay, then we can take plus 10 into star sqrt. So whenever we want to evaluate square root of some suppose some 16, square root of 16 is 4. Okay, so if we want to evaluate that square root of any term, so we have to use this command sqrt, and within first bracket we have to write the number. Okay, see, if we want to calculate these things, this expression value, previously we have already mentioned a value is 5, x value is 2, y value is 8, and if we want to calculate z is e to the power a into sin x plus 10 into square root of y. Then if we press the enter button, then we will get the result of the expression. Okay, so if we want to calculate some complex expression, then you can easily use the MATLAB command window to get the result. Okay, so this is the benefit of we can say the MATLAB. We can easily get the result. Now suppose we want to calculate log 10. Okay, if we want to calculate only log 10, see what will happen. Am I audible, sir? Anyone?
Yes, sir.
Okay,
Yes,
okay.
yes.
My screen is visible?
Yes, sir.
Yes, absolutely.
Okay. Now see, if we want to calculate, suppose log 10. Okay, so log 10 means whenever we evaluate some log of 4, log of 2, log of 10, or log of something, it will be natural logarithm. It will take the base e. Okay, so whenever we write log of 10 within first bracket, we'll get log e base 10, and we'll get some value of log 10. Now if we want to mention the base, how can we do? Suppose we want to mention 10 base. Okay, so log 10 base, if we want to calculate 10, see what will be the result. If the base and the expected value are same, then it will gives you 1. Okay, so this type of operation you can do using MATLAB. Similarly, suppose we want to get the value of sine pi by 4, then just type here sine, then within first bracket just type for pi pi. Okay, and if you want to get sine pi by 4, just write division 4 and close the bracket and press enter. You will get sine pi by 4 value. Okay, this will be approximately equal to sine pi by 4, that is 1 by root 2. Okay, now similarly we can also compute e to the power something. Suppose we want to calculate e to the power 10. So what we have to do? First we will write exp, then within first bracket we have to write 10, then just press the enter button, you will get your answer. Okay. So I think these are the very simple thing. If you see one times, you can do it very easily. Okay. Now we'll go for some simple plot using MATLAB. And suppose we have two data set. Here x is taken as a vector. Okay. X, we have some x values. Suppose x is like 1, 2, 3, 4, 5, 6. We have this data set for x. Similarly, we have another data set y, and that data set is here 3 minus 1, 2, 4, 5, then 1. Okay. Suppose we have these two vectors. This vector length must be same. Okay, if these two vectors length are same, that means the number of elements inside x vector will be same as the number of element inside y vector. If we have these two vector, we can plot it using MATLAB. See, how can we plot? Now, if we want to plot y vector with respect to x vector in 2D, so first we have to write the command plot. Okay, first we have to write plot, then within first bracket, if we want to plot y y vector with respect to x vector, so first we have to write x comma y. Okay, then close the bracket and press enter button. So after some times you will get a figure. So MATLAB is running. I think after some times result will be displayed. Is it visible? Is it visible to all of you?
Yes, it is
Yes,
visible,
yes.
sir.
Yes,
Okay.
sir.
Yes, sir.
So whenever you have two data sets, suppose x, inside this x vector you have some data, and inside this y vector you have some data. That vector length must be same. If you decrease vectors, the elements within y vector, it will be an error. Okay, so always vector length must be same, then you can plot it with the help of MATLAB, just writing plot. And if we want to plot the y variable with respect to x, then you will get this result. Now you can mention the x variable in the in which direction x variable is lies, and in which direction x variable is y variable is lies. That means you can fix the axis. Okay, so if you want to write along x axis x, then first we have to write x label, x label. First you have to write x label, then inside the first bracket just use this symbol and put x. Okay, then if you press the enter button, you can see देखो along x axis you have the variable x. So x axis will indicate the all the x data. Is it visible? Now if we want to mention what is along y axis, you have to write here y label. Okay, then you can put within first bracket your data set y, and then if you press enter button, You can see is in y. Okay, so you can mention x-axis and y-axis. Okay, also you can control the length of the x-axis and length of the y-axis also. Okay, what we have to do for this? First, write axis. Okay, first write this command axis, then put first bracket, then within first bracket put third bracket, then within third bracket first we have to mention what the range of x-axis. That means in this plate you can see it is from 1 to 6. Okay, so anyone can take within 1 to 5 also, the graph within 1 to 5. So if we want to get from the graph from 1 to 5, okay, along x-axis, then we have to write here within third bracket first 1 to 5. Okay, and if we want to get the graph within suppose 0 to 5 along y-axis, then we have to write here 0 and 5, and then if you press the enter button, see what will happen. Just see, axis of x and y are rearranged. Okay, and it is displayed from x-axis from 1 to 5 and y-axis from 0 to 5. So in this way you can control the x-axis as well as y-axis. Now suppose you want to change the line color. Okay, so you can do it very easily. How? Just click on the sign. Okay, and if you click over this line, then right click, you will get a color here. Okay, so according to your choice you can choose your color. So if you choose red color here, then click OK, then it will be converted to red color. Similarly, if you want to change the line width of the line, okay, so you can do it here by taking here 5. Okay, so this will be your line. Now if you want to change the display style of the line, so you have to choose a marker. Okay, so if you choose this marker, your line will be like that. Now you can choose different marker also. Okay, so in this way you can plot some data, but you must remember the vector length must be same. Okay, now suppose we want to plot another things here. Suppose we have x equal to 0, okay, pi by 100, this is semicolon 0. Suppose we want to plot sin x curve. We want to plot sin x curve within 0 to 2 pi. Okay, so what we have to do? First we'll take x variable as 0 colon pi by 100, then we have to put 2 star pi. What is this? देखो, here x is a variable and the range of x is from 0 to 2 pi. So we'll split 0 to 2 pi into several points. So here pi by 100 is the step length. So we have to come from 0 to 2 pi, and we can go from 0 to 2 pi using some step length. So pi by 100 is here the step length. Okay, now then if we take the function as like that, y equal to suppose sine of x, then if we use the plot function, then you have to write here plot, then x is the variable, and we will plot the y function, that is y. Okay, then if we press the enter button, see what will happen. See, this is your y equal to sin x curve. Okay, and similarly, you can mention the axis. You can control the axis. Okay, so this is the easiest way to plot any function using MATLAB. Okay, now suppose we are taking another things, y1 as cos of x, okay? And y2 another function, y2 as sine of x plus cos of x. Now we can plot the three figures, like y equal to sin x, y1 equal to cos x, and y2 equal to sin x plus cos x within a template. Okay, within a figure we can plot the three function. How? See, we have to use here the plot function in different way. See, we'll use here plot. First we'll take the variable x, then first function y. Okay, then again we'll use the variable x, second function y1, then the variable again x, then third function y2. Okay, then we'll close the bracket, and if we press the enter, you will get a figure where you get the three things: y equal to sin x, y1 equal to cos x, y2 equal to figure of sin x plus cos x within 0 to 2 pi range. Okay, now within this figure, if you want to mention which graph is for y equal to sin x and which graph is for y equal to so y1 equal to cos x and which is for y2 equal to sin x plus cos x, then you have to use another comment. You have to use legend, 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 and within first bracket, if you write here y equal to sine of x, okay, then you have to put a comma, then again you can write y1 equal to some cos of x, okay, and then you can use within this first inverted comma, you can use y2 equal to sin x plus cos x, okay, sin x plus cos x. Now after that, if you press the enter button, you can see the figure with mention which one is your y equal to sin x graph. Can you see this figure? Figure is visible or not?
Yes, sir, visible.
Okay,
Yes,
so
sir.
in this figure you can differentiate which one is your y equal to sin x graph, and which one is your y equal to cos x curve, and which one is your sin x plus cos x curve. Okay, or like the previous figure, you can change the marker style. That is, you can choose this way to differentiate from another graph, and you can choose square, and you can choose another way, uh, this, to differentiate from one another. Okay, so I think you can easily understand all of these things. Okay, now in this graph, if we want to label the x-axis, y-axis, and title of the graph, then what we have to do, just write the comment TITLA, okay, then just put the first bracket, and within first bracket you can write the name of the graph. Okay, so within this single inverted comma, you can write anything that will be displayed in your graph. That is, you can write here the graph of different uh, trigonometrical function. Trigonometrical function. So if you write this this comment title graph of different trigonometrical function, and if you press the enter button here, you can see a different figure. See, within your figure you have this comment graph of different trigonometrical function. Okay, so several comment you can use, several line color you can use. Okay, now if you want to use the leveling of axis, suppose you want to label x-axis as s, so you have to put x level within first bracket, just write x here. Okay, and then you can write y level, then you can put here y. Okay, and if you want to write suppose y1, y2, then y3, then it will be displayed in your figure. Suppose just say we have this plot these things, plot of this, and if you enter, okay, now if you use x level here, okay, and if you then put the y level here, and then if you enter, oh sorry, there is a MATLAB error. So first you have to use plot function here, plot function, then you can put the x level. X level is here x, just copy it and paste it here, you can see x. Okay, and if you put y level here, and if you paste it and enter, you will get y. Okay, so these are the comments you can use whenever you plot some graphs. Okay, now we can go for vector. Okay, suppose we want to declare we want to define a vector, that is row vector. So what we have to do, within third bracket, suppose v is a vector, and within this vector we want to store some data 1, 4, 7, 10 and 13, and if you close the third bracket, then if you enter, then you can see within this vector, this is a row vector, it contains 5 elements 1, 4, 7, 10, 13. But if you use the same thing, but if you take the column here, v equal to 1, 4, 7, 10, 13, and after that if you press enter button, your result will not be displayed. Okay, so if you want to show your result, okay, you have to omit the semicolon, okay, from your expression. Now suppose we have another vector, and that vector is like 1, this is column vector. Suppose we want to define a column vector, then for after each element we have to put a semicolon. So 1, then semicolon, 4, then semicolon, 7, then semicolon, 10, then another semicolon, then 13. Okay? After that you have to close the third bracket, then if you enter, then you will see this is a column vector. So if you want to define row vector, See, V will be like that 1, 4, simply 1, 4, 7, 10, and 15. So this vector have only one row. That will be row vector 1, 4, 7, 10, and 13. And if you want to define a column vector, then you have to write W as 1 semicolon 4, then 7, then colon, then 10, then 13. Then if you press enter button, then your column vector will be displayed. Okay. Now suppose we have we want to take a transpose of W vector. See, W is here a column vector 1, 4, 7, 10, 13. If we want to take transpose of this vector, first what we have to do? First, just take another vector D. D is what? W. Then W, you have to put single colon here. Okay. See, this single colon will evaluate the transpose of W vector. So this is a column vector. W is originally a column vector 1, 4, 7, 10, and 13. But if you put this single colon, then it will be, then if you press the enter button, you can see here W is a small letter. So if you use the small letter W, then if you use the single colon as a single inverted comma, and then if you press the enter button, you can see these things. Okay. So you can see W is a column vector 1, 4, 7, 10, 13, and if we want to transpose this vector, just we have to use D equal to W single inverted comma. Okay, then it will display the transpose of W vector. Okay. Now suppose we want to access suppose we want to enter a matrix. Okay, how to enter a matrix in a MATLAB? Suppose we have a matrix A. If we want, if we enter this matrix element, what we have to do? Like within third bracket, we have to write 1, 2, 3. This is the first row. 1, 2, 3. These are the elements of the first row. Then you have to put a semicolon. Okay. Then if your element is second row element is 4, 5, then 6. Just then you have to put another semicolon. Okay. Then if your third row is 7, 8, 9. Okay. You have to put this way. Now, if we press the enter button, see what will happen. It is a matrix. So whenever you enter a matrix in a MATLAB, you have to do this way. A will be the it is a 3 cross 3 matrix, and if you put the first row, you have to put this way: A equal to 1, 2, 3. Then you have to put a semicolon. Then you can put the second row element 4, 5, 6, and then if you want to enter the third row element 7 and 9, you have to do this way. Okay. Now suppose you have a matrix and you don't know sorry, if you want to evaluate the dimension of the matrix, then what we have to do? So just write this comment DIM. Okay, then within first bracket put A and press enter button. Okay. Sorry, it is not working. Let me check. If we want to evaluate the dimension of the matrix, what we have to do? Oh, sorry, we have to put size. We have to put size, not this, not DIM. We have to put SIZE. Then if you include within first bracket A matrix, it will display the number of row and number of columns of that matrix. So you can see here in your A matrix you have 3 rows and 3 columns. Okay, and if you want to know what is the dimension of the matrix, just use this comment size, then within first bracket put A. It will gives you first number of row 3, next number of column 3. Okay, now uh, if we want to take another things, like we want to uh, suppose you have this A matrix 1 2 3 4 5 6 7 8 9, and after putting A matrix, if you want to change some element, okay, suppose you can see in the A matrix third row and third column you have the element 9. Okay, now if you want to change the element 9 to another element, okay, then what we have to do, then just write A, then position of the element. We want to change the element 9 in your matrix A, so we'll put the position 3, okay, comma 3, that is the third row, third column, and we'll put the value. What will be the new value? Okay, we want to change the value of the position third row, third column. Okay, if we put 0, see, if we want to change 9 as a 0 in our matrix A, we have to take this comment A 3 comma 3 equal to 0. Then if we press the enter button, see, in your new matrix, see the previous matrix, we have here 9, but after taking this comment A 3 comma 3 equal to 0, see, 9 is changing to 0. Okay, so in this way you can change the elements of a matrix after putting it in MATLAB. Okay, now suppose we want to access the element 5 of this matrix, then what we have to do, first you first see the position of the element 5 in your matrix. 5 is in second row and second column. So if you write here A, then 2 comma 2, see what will happen, you will get the element 5. Okay, so this it will works like an array. Okay, and a matrix is nothing but an array. So if you want to access, suppose 7, if you want to access the element 7 of your matrix, then you have to write the comment A and see the position of 7. This is in third row and first column, so you have to put 3 then 1. Then if you press enter button, you can see that. Okay, so in this way you can access several elements of your matrix. Now suppose this is your matrix, A is 1 2 3 4 5 6 7 8 0. If we want to get its transpose, what we have to do, so we'll take another matrix B, which is A, then we have to put the single inverted comma. Then if we enter it, see what will happen. Dekho. The original matrix A was 1 2 3 4 5 6 7 8 0, but you can see here it is a row is changed to column, column is changed to row. Okay, so you can interchange row by column and column by row by taking this comment, just writing B equal to A, then single inverted comma. Okay, now we can add these two matrix also. Like previously you have a matrix A and we have another matrix B. Suppose we are taking a new matrix C. If we want to add these two matrix, just write this comment C equal to A plus B. Okay, and then press the enter button. It will add the corresponding element of A and B. But you have to remember that the dimension of A matrix and B matrix must be same. Okay, so if A is also 3 cross 3 matrix or 2 cross 2 matrix, B is also 2 cross 2 or 3 cross 3 matrix, you all know we can add it, we can subtract it, we can multiply it. Okay, so if you want to add two matrix, you just use this comment C equal to A plus B. Now you can also uh, multiply these two matrix. Okay, so we have to use A, then star, then B. So if we have two matrix A and B, okay, and if we want to evaluate the multiplication of these two matrix, then just put A star B, and if you press enter, you will get the multiplication. Okay, now if we want to evaluate, suppose trace of the D matrix. Trace means what? Trace means addition of diagonal element. So if we want to evaluate trace of D, first what we have to do? TRACE. Just write this comment trace and then put your matrix name inside the first bracket. Okay, so here the last matrix is D. Now if you put trace inside the first bracket, if you put D, ultimately what will happen? You can see that is 204. That is the value of trace of D, and you can verify it by adding 14, 77 and 113. Okay, now you can also evaluate the determinant value of D also. Okay, so if you have any matrix A, by using a simple comment, you can calculate the determinant value. For this, you have to just write DET. For determinant, you have to write the comment DET. Then if we write the matrix name here inside the first bracket, suppose we want to evaluate the determinant value of D, so we have to take this way, date of D, and then if we press enter, you can see that will be the determinant value. Okay, and you can verify this result also. Okay, now suppose we have so many things here in the MATLAB comment window. So if we use CLC comment, it will erase all the previous result. Now see, we have a matrix, and the matrix is here 1, 5 and 3, 3. Okay, this is our matrix. This is 2 cross 2 matrix. See, we can evaluate the rank of the matrix using MATLAB also. Okay, and whenever we use hand calculation, we have to do so much things, that is row operation and column operation. Ultimately the number of total number of non-zero rows or columns will gives us the rank, but very simply you can do it with the help of MATLAB. Okay, so if your matrix is like 1, 5, 3, 3, and if you want to get its rank, what we have to do? Just write here RANK, then just put your matrix name here. Okay, so then if you press enter button, you will get the result, and you can verify this result by hand calculation. The rank of A will be always 2, because this is a what? This is a non-singular matrix. So order of rank of the non-singular matrix is what? Is the order of the matrix. So that's why it is 2. Okay, now you have calculated the eigenvalues of matrix in your first semester. Okay, now if we want to evaluate the eigenvalues of the any matrix A, okay, using MATLAB, what we have to do? Just see a simple comment EIG. Just write the simple comment EIG in your MATLAB comment window, and within first bracket put your matrix name. So here your matrix is A, So just put EIG within first bracket A, and then if you if you press then enter button, you can see -2 and 6. This will be the eigenvalue of your matrix. Okay. Now suppose you can verify it by a simple hand calculation. Hand calculation will take many times. So if you use MATLAB command within a fraction of second, you can get the eigenvalue of any matrix. Now if you want to get the summation of all the eigenvalues, what we have to do? Just write a simple comment sum. Okay, then within first bracket just write EIG, then just write your matrix name. So first if you want to add all the eigenvalues of your matrix, so you have to use this command sum, then within first bracket you have to write EIG, then your matrix name, then just close your first bracket and press enter button. It will gives you the summation. You can see it, -2 plus 6, that is 4. Okay. Now suppose you want to take the product of all the eigenvalues of your matrix. Okay, so if you want to get the product of all the eigenvalues of your matrix, just use the command PROD. Just use this command PROD, then just write EIG, then within first bracket write A. Okay, and then enter button, press enter button. Okay, so if you do it, you can see -2 and 6, multiplication is -12. Okay, now suppose we want to calculate, we have already get the eigenvalues. Now if we want to calculate the eigenvectors of the matrix A. Okay, so you all know eigenvector calculation is very much lengthy. Okay, so for each eigenvalue you have to use Ax equal to lambda x equation, and after solving some linear equation you will get the eigenvector. But if you use MATLAB, you can get it within fraction of second. How? See, what we have to do for this? Just use third bracket, write V and then D. Okay, then close the third bracket and just write equal, then just write EIG and A. So in this comment you will get two matrix. One is V matrix, another is D matrix. What is V matrix? V matrix will represent all the eigenvectors of V, and D is what? D will represent all the eigenvalues of the matrix A diagonally. Okay, so after writing this comment within third bracket V comma D, that is equal to EIG A, just press the enter button. You can see this -2 and 6, these are the eigenvalues, and the corresponding first in the first column of V, is the eigenvector corresponding to the eigenvalue -2, and the second column of V will represent what? This is the eigenvector corresponding to the eigenvalue 6 of your matrix. Okay, so using MATLAB you can do many things. Okay, now we'll take another things here. How to solve system of linear equation using MATLAB. Suppose we have three equations. One is what? One is x plus 2y. You have to write this way: 2 star y plus 3z. 3z is equal to 1. One equation. Another is suppose 4. You have to write this way: 4x plus 5 into y plus 6 into z. Okay, that is equal to 1. Then if you have another equation, suppose 7x, so that will be 7 star x and plus 8 star y, that is also equal to 1. And we want to solve this we want to solve this system of linear equation using MATLAB. So if we do just simple calculation using pen and paper, we have to find out a matrix, then a inverse, then we have to do the multiplication with right hand side vector 1 1 1, then ultimately we will get the result. Okay, but whenever we use MATLAB, first write the coefficient matrix of this linear system. Okay, so if you denote this coefficient matrix as capital A, just put all the coefficient 1 2 3, first row. Second row of the coefficient are 4 5, then 6, and the third row will be what, 7 8, and then 0. So this is your A matrix, that is the coefficient matrix of your linear system. Now what is B? B means what? The right hand side element. Right hand side, if you see the right hand side element, you have here 1 1 1, so you can put here 1 semicolon 1 semicolon 1. Okay, so this is your B matrix. Now if we want to get the solution, what we have to do? Just write x equal to, naturally what we have to do, we have to use inverse of A, and we have to multiply inverse of A with B to get the solution of linear system. So what we have to do here, just evaluate inverse using this command INV. So INV, this command will evaluate the inverse of matrix A. So if you write INV then A, it will gives you the inverse of A. Okay, and the solution is what? A inverse B. So we have to take the product of A inverse with B. So if we take the product, see, you will get your result. So this will be the solution of your problem. Okay, so using MATLAB, you can do several many things also, not only solution of system of linear equation, system of non-linear equation, also you can do several other things, fuzzy logic, also other things. But since this is the lecture for introduction to MATLAB, so you can start your MATLAB by using this command. Okay, and if you want to learn MATLAB further, just Google it, MATLAB tutorial, and you will find several PDF, and just use several command, okay, in your MATLAB commando. So slowly and steadily you can learn all these things. Okay, so I think it is already 1:42, so your class will start at 2:10, so I have to stop here. Okay,
So thank you so much, sir. Thank you so much for your effort, and thanks to all the students and the faculty member for patiently listening to the content here. Our HOD sir is also in the session. Sir, would you like to comment here something?
Yes. So many thanks to Dr. Probir Panja. Am I audible, Probir
yes
sir?
sir,
Yes,
yes,
sir, you are
yes
audible.
sir, you are audible.
So we are now traveling with Dr. Mihir Pera.
Okay,
So now we are on the way to our college.
okay,
Anyhow, then many thanks. First, you take us a few comments from student side. So it will be better. Okay, anyhow. Once again from organizing committee. So thank you, Dr. Probir Panja sir. Excellent lecture given by Probir Panja. Amazing for the beginners. So in this international symposium, we promised that we will do some hands-on. So I appreciate Probir sir for take this type of initiative. So amazing, and we hope in near future we will do for advanced MATLAB for our students. If students support us, we will continue this process. Over to Anupam
Okay.
sir, please.
Okay, thank you so much, sir. And dear students, we are always open. Our department, as you know, we are always there with you. If you need any help, any assistance regarding this MATLAB and any other software, so you can always come to us, and we are always there to help you out. And there is one announcement. So here we are ending the pre-lunch session. Now you can have the lunch and come quickly to the class. Our next session will be starting at 4, and the Google Meet link will be the same. So the session will be taken by our Dr. Biplop Singham Mahatro sir. So all of you, please be there at 4 with the same Google Meet link. Thank you so much.